This is the general formula for naming alkynes. And if you already know how to name alkanes and alkynes, this is going to be relatively straightforward for you. And if you don't know how to do that yet, that's fine. You can go and check out those other videos first. So what are alkynes? Alkynes are also hydrocarbons that have a triple bond in them. Now, alkenes, you have E and Z, you have cis and trans. We don't have that with alkynes. In fact, their geometry is 180 degrees. These are sp hybridized. So this bond here is straight, just like my marker. So there's no E or Z, cis or trans. The only differentiation when people talk about them, they'll talk about internal alkynes like this, where they're in the middle of a molecule, or terminal alkynes, or maybe sometimes they might call them external. I don't like that. I just say terminal and internal personally. Terminal where it's at the end of a chain. And how do we name that? Well, like I said, it's pretty similar. We have a prefix, which is the number of carbons. These are all 6 carbon chains. So it would be hex, and use the suffix "-ine", so it would be hexyne. These are both hexyne, just 2 different forms of hexyne. And we need to say where is the bond. So this first one, we would say 1, 2, 3. So this would be 3 hexyne, or some newer professors or books have it hex 3-ine, because I think that's technically the newer convention. This is the one that I see people still most commonly using, but do whatever your professor says to use, because you want to make sure you're getting the most points you can. Now, for this one right here, what would we call this? This would be, here, I'll erase this, because we already know our formula. This would be 1 hexyne, or hex 1-ine. It's that easy. And so alkynes, see what I'm doing that? So we have a big crazy molecule, like, and it's just doing all sorts of stuff. What you do is you find the longest continuous chain that contains that alkyne. So we'd go 1, 2, 3, 4, 5, 6. So that's the way we're going now, instead of 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. So that was actually 7, I'm sorry. See, it's tricky because each end of this is a carbon, because they're straight. So sometimes you can get hemmed up. So don't do that like I just did right there. So now we'd actually count this as a heptyne, because it's 1, 2, 3, 4, 5, 6, 7. And if this is the highest priority group on there, so this would beat out an alkene, but there's other groups that might beat this out. But yeah, like I said, naming those is actually pretty easy. Now there are diines, I guess you would call them. So let's start with this right here. 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. So this would be hexadiene. Yeah, it's a. I personally have never seen a professor put 2 alkenes on an exam, and I've never seen a molecule like this in real life. It does not mean it doesn't exist. Just means I've never encountered it. So I doubt you'll have to know this, but if you do, it's just be so hex is a prefix, and you can say 1, 2, 3, 4, 5. Because 1, 5 diine, hexa 1, 5 diine, or 1, 5 hex diine. Like I said, I don't really think those are that common. I personally haven't run into them. I'm sure there's going to be someone in the comments now telling me that they used it a bunch. That's honestly great. And if you have more experience with naming these and all, please let me know in the comments. But yeah, if you know how to name your alkanes and your alkenes, naming alkynes, it's going to be super easy.